Hi calculus students, it's Mrs. Falzarano here. In mathematics, the phrases average rate of change and instantaneous rate of change can often be confusing. In this lesson, our goal is to help differentiate between the two and understand how each plays an important role in mathematics applications. To better visualize rates of change, we're going to use technology to collect position time data for an object undergoing accelerated motion. Weather permitting, we'll head out to the track. Each of you will line up along a yard marker with your timing device. We'll synchronize our timing devices, and when the 100-yard dash runner hits your yard marker, you'll stop your timing device. You'll share your position time data, and we'll use a graphing app to plot the points and to estimate an equation of best fit for your position function. We'll then use algebra to determine the average velocity of the runner, and we'll use calculus to determine the instantaneous velocity at different points throughout the run. To get started with plotting the data that you collected, navigate to desmos.com/calculator or open the Desmos app on your iPad. On the top left of your screen, select the plus sign and add a table. In the table, enter the yard marker values under the Y column to represent the position of the object or runner, and enter the times under the X column. To save some time, I've already done this with some sample data. Your values should automatically be displayed on the graph. If you don't see the data points, use the subtraction symbol tool or the touchscreen on your iPad to zoom out. Next, to generate an equation of best fit, you're going to start typing y1 is approximately equal to, and we're going to use a cubic to approximate our best fit. So we'll need the variable a, x sub 1 cubed plus b x sub 1 squared plus c x sub 1 plus d. And this will give you your approximation function for our data points. To summarize what we learned in this unit, we're going to be looking at 5 facts to review rates of change. Fact 1. The average rate of change can be found by calculating the slope of a secant line through 2 points on a graph. Fact 2. The formula for average rate of change is change in y divided by change in x, or slope. Fact 3. The instantaneous rate of change measures the rate of change at an instant in time. Fact 4. The derivative is a function that provides the slope of the original function. And lastly, the units for rates of change are units of f of x per change in x. When looking at a runner's position time graph, the units for rates of change would be meters per second. To recap the main focal points of our lesson, recall we used data points to approximate a position function. With that position function, we were able to determine the average rate of change by calculating the slope using 2 points on the curve. Taking the derivative of the position function gave us our velocity function, which could be used to determine the instantaneous velocity at any point along the journey.